Today, we'll be solving LeetCode 994, Rotting Oranges. This is a medium difficulty problem that uses the breadth-first search pattern, also known as BFS. The problem gives us a grid, which is basically a two-dimensional matrix of rows and columns. Each cell in this grid can either be empty, contain a fresh orange, or contain a rotten orange. The rule is that every minute, any fresh orange that is directly above, below, to the left, or to the right of a rotten orange will also become rotten. Our goal is to return the minimum number of minutes needed for all the oranges to become rotten. If it's impossible for every fresh orange to rot, then we return -1. Now, let's carefully think about what's happening. At each minute, the rotting spreads outward from the current rotten oranges to their neighbors. This type of spreading problem is exactly what breadth-first search is made for, because BFS explores level by level, or in this case, minute by minute. So the main idea is to put all the rotten oranges into a queue at the very beginning. This queue will help us track which oranges will rot others in the next minute. Then, while the queue is not empty, we process one layer at a time. Each layer of BFS represents 1 minute passing. For each rotten orange in the queue, we look in all 4 directions. If a fresh orange is found, we turn it rotten and add it to the queue for processing in the next minute. By the end, if there are still fresh oranges left in the grid, we return -1. Otherwise, we return the number of minutes it took for the last orange to rot. Let's now walk line by line through the code to really understand it. First, we need to set up some variables. We will store the number of rows and columns of the grid. Then we create a queue, which will hold the positions of rotten oranges along with the time it took to reach them. At the same time, we also count the number of fresh oranges in the grid. Next, we loop through every cell in the grid. If we find a rotten orange, we add its position and time 0 into the queue, because at the start, they are already rotten. If we find a fresh orange, we increase our fresh count. Then we start the BFS process. While the queue is not empty, we remove the first element, which gives us the current row, the current column, and the minute count for that rotten orange. We then check all 4 possible directions, up, down, left, and right. If the neighbor is inside the grid and is a fresh orange, we turn it rotten, decrease our fresh count by 1, and push this new rotten orange into the queue with time +1. We also keep updating the total time as we go along, because the last level we process will give us the total minutes needed. Once the queue is empty, we check if the fresh count is 0. If it is 0, we return the total time because that is the answer. If there are still fresh oranges left, that means it was impossible to rot them, so we return -1. The time complexity of this solution is O of m times n, because in the worst case, we have to process every cell in the grid once. The space complexity is also O of m times n, since the queue in the worst case could hold all the oranges. And that's how you solve LeetCode 994, Rotting Oranges. Thank you for watching and let's keep learning.